Hi guys, in this video what we're going to do is we're going to work out the perpendicular distance from a point to a line. Okay, so you can see we have a line and we have a point, and the perpendicular distance is where this is making the right angle here. It's also the shortest distance. You can see here, if I go from here to this line, if I go from there to there, which isn't perpendicular, you can see that the length is a lot longer, or even to here it's still longer. So it's sometimes just called the distance from a point to a line. We don't need to say the perpendicular bit. Mathematicians realise that we're looking for the shortest distance from here to here. Now you can see here what we have is we have an equation of the line, and it has to be of the form ax plus by plus c is equal to 0, and then all we need then is a point, guys. The perpendicular distance formula is given by p, I usually use d, guys, is equal to the modulus of ax1 plus by1 plus c all over the square root of a squared plus b squared. You don't have to know where this particular equation comes from, and you don't have to worry about remembering it. It's in your tables book. So we'll just do a quick example and see how it works. So the first thing we've been asked is to find the perpendicular distance from the point 4 minus 1 to the line 3x minus 4y is equal to 7. Now notice the first problem we have here is that this is not of the form ax plus by plus c is equal to 0, because we don't have equal to 0 here. So that's the first thing we need to work out. So let's sort that out. We'll get 3x minus 4y minus 7 is equal to 0. And now we have it of the form we need. We can then label everything that we're going to use. So my point is x1, y1. This here is ax plus by plus c is equal to 0. And now it's just a case of putting everything into the formula. So I'm going to call it d instead of p, makes no difference. So d is equal to ax1 plus by1 plus c modularized all over a squared plus b squared square rooted, and just a case of putting the values in. D is equal to the modulus. A is equal to 3. x1 is equal to 4, just see it there, they're all labelled, plus b. B is equal to minus 4 in this, okay, and then y1 is equal to minus 1, so put that there, plus c, and you can see plus, and we have minus 7 is what c is here. That's going to be modularized, and it's all going to be over a squared, which is 3 squared, plus minus 4, which is the b, all squared, square rooted. Just a case now, just working it out. So for the first one, 3 times 4 is 12, minus 4 times minus 1 is plus 4, so plus 4, minus 7, modularized on the top. 3 squared plus 4 squared, so what we have there is 9 plus 16 square rooted. And we just come up here. So what we now have is 12 plus 4, which is 16. 16 take away 7, which is 9. Okay, so we've got 9 on the top. So d is equal to 9 all over square root of 25. D is equal to, the modulus of 9 is just 9, square root of 25 is just 5. So what we now have is D is equal to 9 divided by 5, okay, or 9/5. To find the perpendicular distance between two parallel lines, what we need to do is just get a point on the lines and then find the perpendicular distance from there. So you can see here, we've been given two lines that are parallel, x plus 2y minus 4 is equal to 0, and x plus 2y plus 7 is equal to 0. You can tell that they are parallel, the slopes are the same. Minus a over b here will be exactly the same as minus a over b here, so that's not a problem. So we need to find a point on one of these lines. It doesn't matter which one we do. So let's have a look at x plus 2y minus 4 is equal to 0. So what I'm going to say, all right, let x equals 0. So I'm going to find out where it crosses the axis. If we do that, we get x equal to 0, which means we have 0 plus 2y minus 4 is equal to 0. We can then get 2y is equal to 4, y is equal to 2. I now have my coordinate. My x value is 0, that's the one I picked, and the y coordinate is 2. Now, it doesn't matter what coordinate I decide to choose, or what value of x, what value of y, as long as I can get a coordinate on that line, then I'm fine. Now, if you look at the diagram, 0, 2, essentially what we're saying is that where that green thing is, this now is my 0, 2 line, or my 0, 2 coordinate, and that's on the line x plus 2y minus 4 is equal to 0. The other line that we have is x plus 2y plus 7 is equal to 0, and I'm trying to find the perpendicular distance from here to this line here. It's now just a case of putting it through the formula. Okay, so the formula we know is d is equal to ax1 plus by1 plus c modularized all over a squared plus b squared square rooted, and we'll just put the numbers in. So here we go. D is equal to A. A is equal to 1. Okay, so using this up here. X1 is equal to 0 plus B, which is 2, by Y1, which is 2, plus C, which is 7. We're going to modulise that. All over A squared. Well, A was equal to 1, so 1 squared plus 2 squared square rooted. Work out the top, so we've got D is equal to 0 plus 4 plus 7, so we've got 11 on the top, modularised. All over 1 squared plus 2 squared is 5, so we have the square root of 5, and the modulus of 11 is just 11, so D is 11 over root 5, and we're done. So let's have a look at the second example. It says find the equations of the two lines which contain the points -5, -4, and which are a distance of root 17 from the point 1, 3. So let's draw this first of all and see what's going on here. So we've got a point down here which is -5, -4. And we've got a point 1, 3. So 1, 3 is going to be roughly up here somewhere. So 1, 3. And it says find the equations of the two lines which contain the points -5, -4, which are a distance. And remember, if we see the word distance, it means a perpendicular distance of root 17 from the point 1, 3. So what we've got is something like this. We've got two lines that go through -5, 4. So here we go. There's one going in sort of this direction. And we've got another one going in sort of this direction. So there's two lines going through. And what we're saying is it's a perpendicular distance of root 17 from the point 1, 3. So perpendicular, that's going to be this here. That's going to be that right angle. But it's also going to be this one to this line here. We're going to get perpendicular. And both of them are going to be worth root 17 and root 17 in that direction there. Now, if you get the setup of this correct, i.e. you draw this correctly so you can see what's going on here, this is going to make things a lot easier for you to get this right later. So we know we're going to have to be using the perpendicular distance formula. We also know the perpendicular distance formula, if you can't remember it, D is equal to AX1 plus BY1 plus C modularized all over A squared plus B squared square rooted. So that's the formula we're going to be using. And hopefully you can see here that the only distance that we have is this distance here, which is the root 17 going from 1, 3. Okay, which means that the two lines that we're going to find, hopefully, because it says to find the equation of the two lines, is this line here and this line here. I'll call them L1 and L2. So L1 and L2. So remember, that means that we've got to get the lines in the form of AX plus BY plus C in order to put it into this formula. And we don't know much about this line. The only thing we know is that this line contains the point -5, -4. So let's just see what we can do with that. We have y minus y1 is equal to mx minus x1. Now I don't know what the gradients are or the slopes are, but I do know, like I said, I do know that this -5, -4 is going to go through the point here. So let's just put them in and see what happens. So I have y minus -4, which is y plus 4, is equal to m, x minus -5, which is x plus 5. And now what I'm going to do is I'm just going to multiply out the right hand side. I'm going to get y plus 4 is equal to mx plus 5m. And then I'm going to take everything across to the right hand side. So I'm just going to bring this across and this across. So this is going to go across and this is going to come across. And if I do that, I'm going to get mx plus 5m minus y minus 4 is equal to 0 on the left hand side here. And I'm looking to get it of the form ax plus by plus c is equal to 0, so I can put it into this formula up here. Okay, so there's my x's, there's my y's, and that doesn't have an x or a y on it, and that doesn't have an x or a y on it, so that must be my c. So I'm just going to rearrange it, and I'm going to have mx minus y plus 5m minus 4 is equal to 0. And now I have my, just going to write above it, ax plus by plus c is equal to 0. So my a in this particular one is m, my b is minus 1, my c is this whole thing here, this 5m minus 4. Now what I'm going to do is I'm going to stick it into the perpendicular distance formula. I'm going to do it here, and we know that d is equal to ax1 plus by1 plus c all over a squared plus b squared. Now this is the important bit. We know what the distance is, because the distance from, it says from a distance from the point 1, 3. So here's the distance. We know that that distance could be equal to root 17. And the point we're using is 1, 3. Now that's really, really important, because you can easily get confused whether you're going to use this minus 5 and minus 4, or you're going to use this one. But it's the distance from this point here, the perpendicular distance from this point. Okay, so it's really, really important that you get the correct coordinate here. So what I'm going to do by the side here is I'm just going to write the coordinate system I'm using, which is 1 and 3. So there it is, so I don't forget. I'm now going to start substituting in everything I know. So I know that root 17 is equal to, and it's the modulus of a. Well, a is, remember, we're using this down here. So a is equal to m. So I have m by x1, and x1 here is 1, plus b, which is minus 1, because it's what's in front of the y, by y1, which is 3, that's the y coordinate, plus c, so it's plus 5m minus 4, all modularized, and that's over a squared, which is m, so m squared, plus minus 1, all squared, square rooted. And now it's just a case of tidying this up. So we've got root 17 is equal to, we've got m by 1, so we've got m minus 3 plus 5m minus 4 modularized all over m squared plus 1 all square rooted. I'm now going to take this and multiply both sides by the root m squared plus 1 to get up to here. And I'm going to tidy up this modulus here. So we'll do that next. So what we now have is root 17 multiplied by root m squared plus 1 is equal to the modulus, and m plus 5m here. So m plus 5m is 6m. And then what we have is minus 3 minus 4, which is minus 7. So that there is the minus 3 minus 4. So minus 3 minus 4 is equal to minus 7. Okay, the next thing I'm going to do is I'm going to square both sides to get rid of the square roots and to get rid of the modulus. Okay, so if I square both sides, let's just do this in red to show what's going on here. So I'm going to square that, and I'm going to square that, which means I'm going to get root 17 squared. So I get this root 17 by root 17, and that will give me 17. I'm then going to square this square root here. So this is going to be square root squared, which means I'm going to be left with just m squared plus 1. Don't forget it's in a bracket. Is equal to, and it's going to be 6m minus 7 all squared. Okay, we're going to get the left hand side out. We get 17m squared plus 17 is equal to, this is just a simple binomial, so 6m by 6m is 36m squared, minus 42m doubled, so that's minus 84m, plus 49, and we've got rid of that bracket there now. I'm going to take all over to the right hand side and try and keep everything positive in terms of the m squares. So I'm going to have 19m squared here. We've got minus 84m, and the m's and the coefficient there is, we're going to take the 17 across, so 17 from 49 is 32, and that's equal to 0. Now I'm just going to move the page up so we can carry on with this. There we go. So just keep going. So there we are. And we're going to solve this. Now you can solve this any way you like. You can solve it by factorisation, or if you can't see it, use the formula. So it's 19m here. You can see that 19 is a prime number, so 19m and m. And the coefficients that we're going to stick in here are going to be m minus 4 and 19m minus 8 is equal to 0. Okay, and that then is going to give us our two values for m. So 19m minus 8 is equal to 0, or m minus 4 is equal to 0, giving us the two values. 19m is equal to 8, m is equal to 8 over 19, so that's the first gradient, or the first slope, and the second one then is m is equal to 4. Now don't forget, we haven't quite finished yet because it asks for the equations of the lines. Okay, so don't just stop there. Ask for the equations of the lines. That's what we need to do. And we can substitute it just directly into this here, where everything's in terms of m. Look, so we've got mx minus y plus 5m minus 4 is equal to 0. So we'll bring that down. So we've got mx minus y plus 5m minus 4 is equal to 0. So if m is equal to 8 over 19, what we get is 8 over 19x minus y plus 5 by 8 over 19 minus 4 is equal to 0. We're going to multiply everything by 19 to get rid of the fraction, and we get 8x minus 19y plus, we've got 5 8s are 40, and then we've got minus 4 times 19, which is 76, and that's equal to 0. 8x minus 19y, 40 minus 76 is minus 36, is equal to 0, and that there is our first equation. For the second one, just go up to the side here. If m is equal to 4, this should be a little bit easier. What we have is 4x minus y plus 5 by 4 minus 4 is equal to 0. Again, all I've done is I put 4 into this formula here for m. Okay, tidy it up a bit. We get 4x minus y plus 20 minus 4 is 16 is equal to 0. And we are done.